Hello everyone, welcome back to GGI Geospatial Solutions training. Today we are going to continue to talk about the DJI Enterprise Industry Solution for AEC. This is the part 2. So following our part 1, we have already talked about the introduction of AEC and the bidding pre-construction. So in the part 2, we are going to talk about the earthwork, vertical building, and summary. Okay, so the earthwork period, the critical use case will be the quantity reports, cut and fill analysis, and the overall site progress. So why this is important? It can provide the accurate snapshots of how much earthwork is on site at any given date, compare the progress over time, and the contractors, they can gain the insights about the area's topography and receive a survey that accurate down to the centimeter. And in the foundation part, so there are also some critical capture milestone. And why this is important? Because it can capture in the location of the structural elements, means you can ensure that everything is in the right location. View aerial imagery to get a holistic view of progress as foundations are being installed. The drone usage scenarios, there are, for example, stockpile volumetrics. If they use the traditional way, there are some challenges. For example, the manual mission always takes days or weeks in hard to reach locations where the personnel can be exposed to hazardous materials and unable to render the detailed model that yield accurate volume measurements. But if we use the drone solution, it can quickly deploy the drone in hard to reach areas to collect the high resolution data. And we could fly as regular as needed. Also, with the help of DJI Terra, we can provide the volume, distance, and surface measurement. In the progress monitoring period, so same if we use a traditional way, so it means tracking the construction projects involving many teams and a large size is very difficult. So if we use the fixed cameras, it often fail to capture the critical progress information, and the large quantity of view footage can draw out critical details. But if we use a drone solution, drone can create accurate 2D and 3D model for the site on demand. The 3D model can be used to track dynamic changes or daily progress. There's a drone use cases with volumetric calculation. Shuffle and drone, they using the drone data to report on the environmental and safety concerns in Canada. Their challenge is they need to calculate the volume of the tires on the recycling site. If they use the traditional way, it will be harm to the personnel and it cannot easily get the accurate data. But they choose the drone solution and to finish this job very quickly and very accurate. So if you want to know more details, please scan this QR code for more information. And there's another use cases. They use the drone cooperated with Beam. So UK-based Well Brothers branches the drone surveying to improve the road construction efficiently. They are facing a 29 million pounds project. If they use the traditional surveying, it would take weeks. They need more time and a more cost-effective way to gather the information. So finally, they chose the drone solution. It is saving the time, and together with DJI Enterprise solution with the propeller, so finally they get the rapid and cost-effective results. So same, if you want to know more information, please scan this QR code for the real case. And there's a highway construction site use case. This is a highway construction in Korea. So they use the M350 plus L2 to extract the ground based on the point cloud. Thus, they created a counter line and then calculate the cut and fill volume. Okay, next is a video use case. Let's see together how does the GGI Geospatial Solutions change the AEC industry.
Yeah, it takes off pretty quick. I like it. Pretty good handling. Really responsive. My name is Justin Russell. I work for Fiore & Sons. I've been here 18 years. We do earthwork, demolition, site work, and utilities. When we started this project, it was nothing but an open field like you see in the background there. We're over-Xing all the lots out here to stabilize them for residential. We got about 6 weeks left here. As we fly it every week, we're getting closer and closer to the end. Once we're done, we'll be able to have a final topographical map of the area, hopefully delivering within a plus or minus 2/10 spec to our client. The traditional way of surveying is you set up a base and rover or a total station. You walk the site or set it up on an ATV or a truck and literally go along and put the rod on the ground and take a shot every 15 to 20 feet. Now we use a drone. We get such density. We're getting a point about every 2 centimeters horizontally, and vertical is way more accurate. The density is unreal.
So before we get on site, we're going to capture those existing conditions to give us an upper hand on our bid, and as well as just having great observations of what we're going to be moving into as an earthwork company. So with drones, what we're trying to accomplish is just a smoother workflow, capturing the data without having to do it manually and occupying those locations ourselves, as well as getting more accurate data to use for volume computations and just observations of our job sites in general. Better observations using photos, surfaces, and just speeding up the entire workflow as a whole.
This site's about 85 acres. Traditional survey would take us 2 to 3 days to topo this site accurately. We can knock that down into about an hour with the drone, so that's huge cost savings right there.
Most of our customers are doing earthwork surveys. They're using the PPK workflow to upload to our platform to create an accurate survey to create measurements based off of that.
So I have my data set from where I flew yesterday on the 17th here, and I'm going to compare that to the flight that I did last week, just to make sure that the accuracy is good and that I can depend on this data for volume computations and just general observations of the site. So using Propeller, we're just going to compare this to our previous survey. Once I have verified that the accuracy is good, seeing here about a fill of 100th, I can see that the accuracy is good, and then I can utilize this for other measurements. So discarding out of this one, I can then take a measurement against my design and see exactly how much fill we have to put left in this hole. After I've drawn a boundary around this fill area, Propeller is very quick to give us a quantity and a sort of visual shading of what needs to be done in this area in order to accomplish the drainage plan or the proposed design.
Ooh, that gimbal is responsive. It's actually really more responsive than the Phantom 4. I'm actually having a good time right now.
So for the Map 3, the impressions that I had immediately were that it's going to cut down on my time mapping the site, just with its shutter speed, the speed that it's moving when it's capturing that data, the battery life, Also plays a huge part because I'm in the air longer and I'm not having to constantly bring back that drone and put a new battery in it. So the mapping process is just pretty much cut in half when you introduce the Mavic 3.
I think the features of the Mavic 3 Enterprise are great. The fact that it's more affordable makes it really easy to scale, and I think our customers are going to have no hesitation when upgrading their fleet.
Okay, wow, excellent cases, and good job for them. Okay, let's move on. And by the way, if you want to see this video again, and please scan this QR code. There will be the case in YouTube. Okay, next part, let's talk about the vertical building. So the first period will be the architecture engineering. If we use the traditional way, it will usually lack a precise position and always cost time and labor. And besides, the 2D designs are unable to illustrate the special information required. The beam designs can be quite different from the reality model. But if we use the drone solution, then there will be not a problem. So the 3D model creation can be accurate position data, and we can even do the comparison between different models, between different days or even weeks, to see how the progress going on. And when it comes to the steel structure, so the visually documenting progress of structure steel and can be taken on a weekly or monthly basis, that can help with the quantity and schedule comparison. Okay, there's some use cases. First is the drone for inspection. It comes from our general contractor, Hansel Phillips. They are pushing the boundary for drones in the construction. The traditional challenges, like we have introduced in the beginning of the part 1, so it's usually a time-consuming and dangerous job. What's more important is the manual inspections do not produce standardized digital results. But if we choose the drone solution, the operations can now be 8 times more efficient. The client, they decreased the average man hour, so from 80 to 128 hours down to 16 hours with the drones. So this technology can dynamically reduce the costs and in many cases eliminate the needs of putting crews in harm's way. The next case is drone for construction site management. The drones has speed up the construction for Fort Walls Landmark Arena. The traditional challenges is need for holistic solution for management and the project teams to better be aware of real-time advancements, setbacks, and potential risks. So using the drone solution, so the surveying has been improved with accuracy frequently, and turnaround times. The inspections was easier with both visually and the thermal aerial imagery, and the site mapping are enabled to track the progress with better visibility. Okay, there's another video use case. So let's see together how DJI LiDAR helps the construction site to better capture the detailed and complex building structure. This is from the real use case in Everton Stadium development together with our partner Heligai. Okay, let's see together.
I'm Aaron Scallion. I work for Select Plant Hire and I look after the UAV department. So in the first stage of the project, we used the L1 to monitor the sand infill of the dock. Now we're using the L2, we've been able to see the key benefits coming through.
We've worked with Aaron and Select Plant Hire for the Everton Stadium project in order to help them use LiDAR as well as photogrammetry. We also do site visits to make sure that they're getting along with the hardware okay and getting the deliverable results from their data set.
We're using the drone technology quite extensively on this particular project. So as well as doing normal progress videos and updates, we actually use it in our immersive suite, which is a digital area where we coordinate construction work, logistics, plant movements, craneage. We can look at our digital 4D model, we can look at our construction program in its traditional format, and then we bring the drone technology in to see where we are in terms of reality. So it gives us a complete spectrum in terms of theory, model, reality. So it's proved to be extremely effective.
So Aaron and the team at Select Plant Hire have used various data collection methods on the Everton Stadium project. They include nadir with the camera angle pointing straight down, oblique with the camera pointing at an oblique angle towards the facades of the structure, as well as a number of manual missions in order to capture data around features of interest.
The L2 has increased efficiency, gathering more accurate information and been able to process it faster through DJI Terra. We're able to get real-time, fast and accurate data on a daily basis. By using the L2, we're able to generate data for earthwork movements, including volumetric data. This is invaluable on the size of the sites that we have.
There are some clear improvements in the data quality from the L1 to L2. The improvements of the sensor mean that you can fly faster for greater efficiency and collect more accurate data even when flying higher. It has better vegetation penetration because it now has 5 returns instead of 3, and it also has an improved RGB camera, which means that you can have greater efficiency when collecting photogrammetry and LiDAR data. The team on site captured 5 flights, which lasted for a total of 35 minutes. They then took the data to DJI Terra and processed it into a standardized output so it could be imported into other software for further manipulation and processing. Some new features in DJI Terra include the capability to classify the ground data as well as produce a DEM from your LiDAR data.
Using DJI Terra, we were able to process large amounts of data on a very fast turnaround.
So when we processed the data in DJI Terra and in Terra Solid, what we found is that the data was very clean, and when we compared it to our checkpoints, it was also very accurate to the coordinate reference system which we collected.
The project itself is great for the City of Liverpool. I always tell everybody that's coming to work on the project, you don't have to be an Everton fan to work here. It's creating opportunities way beyond the boundaries of this particular project.
So Heli Guy's been working with Langer Oak for just over 4 years. During that time, we've assisted with regulatory training, workflow support, as well as hardware supply.
Heliguy's been very supportive in directing us into the latest technologies and helping us understand the benefits of the various drones on offer from DJI.
So we're always looking at how we can improve our processes and our management tools. I'm keen to see how we can use the technology on a more internal basis. So we're now in the critical path of our programme, which is running through the internal works. So internal partitions, walls, rooms, mechanical, electrical services. And traditionally that's harder to demonstrate digitally and in a model. So if we could have something equivalently as good internally as we have externally, that would be the next big step forward. So I'm open to ideas.
Okay, great case. Okay, so if you want to see it again, please scan this QR code for this video. Okay, the last part is a summary of the course. So, okay, let's first take a look of the documentation milestones throughout the project lifecycle. So there will be pre-construction, substructure, structure, exterior, interior, and closeout. So except the interior, so the drone cannot be used. So in the rest of the workflow, the drone can play a huge role. And our target customer, there will be general construction companies, including the national and regional, and for example, there will be local subcontractors, and even the state and federal transportation organizations. And what's the next generation? So we believe the next generation of DJI Geospatial AC solution will belong to DJI Dock. So it can reduce the manpower with much higher data collection frequency, a remote operation across different team members, and with high accurate, precise data capture. So it can also generate lots of data and the final results. For example, there will be also mosaic, DSM, 3D model, point cloud, DM, counterline, DXF, stockpile, cut and fill analysis, you name it. So the latest will be the dock tool, so it can automatically take off and automatically landing, and even fly in a very complex environment, for example in heavy rains or with very heavy dust. And the single unit can cover with a radius coverage of 10 kilometers. So by using the dock, we could do the access and the site digitalization. So the 3D model could with the centimeter level accuracy. So the area mapping mission planning with Flight Hub tool, and we could also do the cloud mapping on Flight Hub tool. So accuracy will be horizontal 3 centimeters, vertical 5 centimeters. And the models can even be downloaded and imported to any third-party software for further analysis. So in this case, the application will be the digitalization of a construction site, and we can tracking the earthwork progress of a construction project. We could do the cut and fill analysis in a mining or in a coral site. Okay, there's a video has showed how it works in the Flight Hub tool. And this is the final result. With cloud mapping, we could get a 3D model. Okay, and with dock, we could also do the progress management. So for example, now it supports the 2D map comparison. So just drag your mouse left and right, so we could do the comparison to visualize the changes and the progress. And the progress management, so side we could monitoring the site conditions routinely throughout the project lifecycle. We could plan a flying route based on our needs. We could capture the pictures, video, panorama of the site weekly or even days. So we could monitoring the key milestones and the actions. We could visualize the construction progress and share the updates with the team. And you can see all the data has been captured and storage in the cloud, and we could do the comparison just as we want to better face the progress management requirements. And it can also cooperate with the BIM, so we can overlay the map, the models with the design files and BIM models for further analysis. So there are two pictures has showed the 2D map overlay with the design file and the 3D model overlaid with the BIM model. Okay, this is the end of the AEC course. Thanks for listening. So hoping this course could be helpful for your daily job. So thanks again. So let's continue meeting you in other courses. Bye bye.